Cement and concrete may seem similar, but they're actually different. Cement is a key ingredient in making concrete, along with water and aggregate. The process of making cement is made up of several steps, starting with getting the raw materials and ending with packing and shipping the cement. Even though each company has its own way of doing things, here are some general steps for making cement. Stage 1. Raw materials extraction. Soft rocks like clay and chalk and hard rocks like limestone and slate are the main things that are used to make cement. The rocks are quarried and then taken to a place where they are crushed. Dry goods are usually moved by trucks, train cars, or conveyor lines, but it depends on the location. Pipelines are sometimes used to deliver those that are wet. Stage 2. Crushing and grinding. The first step is to break the raw material so that the rocks are smaller. Hard rocks are broken up by jaw crushers, hammer mills, and cone crushers in cement plants. The hard rock is then turned into a fine powder called raw meal by a process called roller milling. It is also possible to handle soft things like clay and chalk. In wash mills, they mix soft stuff with water to break it down. This makes a mush. They put the sludge through a fine screen to get rid of any big pieces that are still in it. Stage 3. Preparing the raw mix. Next, cement makers will mix different amounts of the raw materials to get the exact mix of cement ingredients they need for the type of cement they make. This mix also changes depending on what the cement is supposed to do, how easy it is to get the raw materials where it's made, and how it's made. Most of the time, limestone dust is the main ingredient in the mix. The amount of limestone dust is usually between 80% and 95%. Between 5 and 20% of the mixture is clay or rock dust. If the cement is a certain type, it may also have silica, iron oxide, alumina, or other ingredients added to the mix. The amount of these chemicals usually vary from 1% to 10%. Stage 4. Preheating and precalcination. The raw mix preparation process is then followed by preheating and precalcining the raw mix to make the process use less fuel and make more. The raw materials are heated to 800 O or 900 O Celsius in a machine such as a tower preheater or a vortex preheater. During this step, any water or carbon dioxide is taken out of the mix. Some of the chemical reactions that are needed to make cement start with this step. Stage 5. The kiln phase. The most important part of the process of making cement is the oven phase. By reacting with calcium and silicon dioxide molecules in a number of steps, clinker is made from the raw mix. While the process is complicated, the following events can be put in order of how clinker is made. Evaporation of free water. Evolution of combined water in the argillaceous components. The calcium carbonate, CaCO3, is heated up to make calcium oxide, CaO. When CaO mixes with silica, the calcium silicate is made. The liquid phase is formed when CaO reacts with the aluminium and iron-containing parts. Formation of the clinker nodules. Evaporation of volatile constituents, for example, sodium, potassium, chlorides, and sulfates. The reaction of excess CaO with the calcium silicate forms tricalcium silicate. Based on the change in temperature inside the kiln, the aforementioned events can be summed up into 4 main stages: 100 degrees Celsius, 212 degrees Fahrenheit. Evaporation of free water, 100 degrees Celsius, 212 degrees Fahrenheit. Minus 430 degrees Celsius, 800 degrees Fahrenheit. Dehydration and formation of oxides of silicon, aluminum, and iron, 900 degrees Celsius, 1650 degrees Fahrenheit, minus 982 degrees Celsius, 1800 degrees Fahrenheit. CO2 is evolved and CaO is produced through calcination, 1510 degrees Celsius, 2750 degrees Fahrenheit. Cement clinker is formed. A 3-degree tilt is added to the kiln so that the material can move through it over the course of 20 to 30 minutes. When the raw mix gets to the bottom of the kiln, clinker starts to form. It comes out of the kiln in lumps about the size of marble. Stage 6. Cooling. Using air or water, clinkers are quickly cooled to between 100 O and 200 O Celsius. Because it changes the texture of the clinker, this process is very important for making sure the quality of the finished cement product. Rapid cooling helps the clinkers harden their mineral makeup, makes them easier to grind, stops them from rehydrating, and keeps them from breaking. Stage 7. Mixing and final grinding. When the clinker cools down, it is mixed with a number of other materials, such as gypsum, fly ash, and limestone. These additions help control how long cement takes to set, prevent fires, make the cement easier to work with, and lower its shrinking, among other things. A ball mill or a machine like it takes the clinker and chemicals and grinds them into a fine powder. Stage 8. Packaging and distribution. The cement is moved from the mill to bins for storage. The cement is stored in bunkers and then put into bags and sent to customers and wholesalers. Reasons to use cement when building. There are many good reasons to use cement when building, and they include: it makes good business sense. There is proof that it will last for thousands of years, so you know it's strong and sturdy. And the longer the building stands, the stronger it gets. It doesn't mind heat and can handle big changes in the weather. A very small amount of upkeep is needed. It can be used in many ways. It can be used to build buildings or pave streets. It can also be used to make park benches or bridges over the water. Fire doesn't destroy it. Because of this, it can be used to build important buildings like schools, hospitals, museums, libraries, and banks. Ability to last. Because it naturally keeps heat and cold out, buildings made of it don't need as many heating and cooling systems, making them more energy efficient. From now on, how will they make cement? Every day, people find new ways to mix cement and use it. New technologies have made it possible to make cement faster, better, and cheaper. This means that cement will continue to be an important building material for many years to come. As technology has improved, it has also brought about new uses for cement, like artistic micro-cement, and ways to build with cement, like 3D printing. A Dutch microbiology professor named Henk Jonkers recently made bioconcrete that can fix itself when it cracks. By adding certain bacteria that make limestone to the cement, he made a living material that is very strong and will protect the steel supports inside from water damage. Because of these improvements in technology, we think that cement will remain one of the most important building materials and will continue to shape the skylines of our towns for another 100 years.